Let's do a little practice with balancing reactions. I recommend trying this on your own first until you get stuck and then using the video. So for the first half of this worksheet, it just wants us to do an atom inventory. So it wants us to tell you if the reaction is balanced or not. So copper's on the left of the arrow, there's 2. Copper's on the right of the arrow, 2. Oxygen's on the left, there are 2, and remember that 2 carries through the entire thing, so this is 2 copper, 2 oxides, so that means there are 2 oxygens. So yes, this first one is definitely balanced. Number 2, we've got some iron, hydrogen, and oxygen atoms. So let's get set up. There are 3 irons on the left, and on the right, there are 2 of this entire molecule. So some people like to write it out when they're first learning so that they can really count up what's there. 3 irons and another 3 irons make 6 irons. So we could stop here and just say no, but let's check out everything else too. So we've got 4 H2Os. That's 4 H2s. 4 times 2 is 8. And on the right side, we've got 4 times 2, 8. Oxygen's on the left. Remember that 4 carries all the way through. So that's like saying that we've got 4 H2O molecules, and there's 1 oxygen in each, so that's 4 oxygens. On the right side, remember we drew these out. There's 4 oxygens and another 4, or you could just do 2 times 4, 8. So the only thing that is balanced here are the hydrogens. Number 3, we've got Na, Zn, and I. We've got 2 Na on the left, and we've got 2 on the right. We've got 1 zinc only on the left. Sometimes people get confused and they think that that 2 is for the zinc also. No, if there's nothing there, it's always a 1. So 1 zinc on the left, and on the right side there are 2 zincs. So already we know this is not balanced. For the iodines, there's 2 on the left, and this 2 carries all the way through here, so there's 2 iodines on the right. We've got carbons, hydrogens, and oxygens in number 4. 2 times 12, we've got 24 carbons on the left and 24 on the right. Oxygens, or hydrogens, excuse me, 2 times 26, what is that? 52 hydrogens on the left, and 26 times 2, 52 hydrogens on the left. 37 O2s. So we've got to do 37 times 2, 74 oxygens on the left. Now we've got 2 spots with oxygens on the right, so we've got to be careful. We've got 24 CO2s. That's 24 times 2, 48 oxygens. Plus another 26 oxygens. That makes 74 oxygens. So this is definitely balanced. Pro tip for this last one: if there is a polyatomic ion like sulfate that stays together on both sides of the arrow, you can keep it all together as one thing. Same with the hydroxide, OH. Since it stays together on both sides, we can just count that as like one atom. We've also got calcium. So we've got 2 aluminums on the left, and we've got 2 aluminums on the right. Sulfates, we've got 3 SO4s on the left, and we've got 3 SO4s on the right. OH, 3 calcium hydroxides. For each one of those, there are 2 hydroxides per molecule, so 3 times 2 is 6. And then here we've got 2 times 3, we've also got 6 hydroxides there. We've got 3 calciums on the left and 3 on the right, so yes, this is definitely balanced. Now let's do some actual balancing. It's still nice to start with an atom inventory. So for the first one, we've seen this many times. Maybe we don't need to do an atom inventory, but like I said, it's still nice. 2 hydrogens on each side, 1 oxygen on the left, 2 on the right. Uh-oh, we got to do something here. So I notice my oxygens are off. There's only one thing I can do. Unless it's an odd number, I guess that does work. Make odd numbers even is always one of my hints. So now we've got 2 oxygens instead of 1, but be careful, we just doubled our hydrogens. So now our hydrogens are not balanced. But on the right side, we can add a 2 out front here, and now we've got 4 hydrogens on both sides. You can leave this last one blank, or you can put a 1 in there. It doesn't really matter. So the answer, the coefficients would be 2, 2, 1. Next one, we've got Na and Cl. 1 Na on each side, 1 Cl on the left, and 2 on the right. So this is not balanced. There's only one thing we can do. Fix our chlorines so that they're even, but uh-oh, now our sodiums are off. So what can we do on the right? We can add a 2 in front of the Na, and now everything is balanced. Remember, you can never add a subscript. Like, we couldn't have just made that Na2, because Na is not in Hofbrinkel. So you can't start adding the little numbers, the subscripts, because that messes up the molecule. Let's look at number 3. Aluminum and chlorine. 1 aluminum on the left, 1 on the right. 2 chlorines on the left and 3 on the right. Coming back to my hint, make odd numbers even. If I put a 2 out front, 2 times 3 makes 6 chlorines. And now there's 2 aluminums. So I need to fix my aluminums on the left side and my chlorines. How can I get this to be 6 chlorines? What times 2 is 6? If I put a 3 there, then I'm good. Now I've got 2 aluminums on each side and 6 chlorines on each side. Lithium and fluorine. 1 lithium on each side, but uh-oh, 2 fluorines on the left and only 1 on the right. We know what to do. Put a 2 in front of my fluorine, which messes up the lithium, but I can easily add a 2 in front of the lithium on the left side, and now I'm balanced. A lot of atoms in this one. Hydrogen, sulfur, potassium, oxygen. I've got 3 hydrogens on the left. H2 plus another 1. I've only got 2 hydrogens on the right, so I know we're not balanced. 1 sulfur on the left, 1 on the right. 1 potassium on the left and 2 on the right. 1 oxygen on the left and only 1 oxygen on the right. Never start with hydrogens. That's just a bad idea. Start with a different element. So I'm going to choose K. I'm going to put a 2 in front of the K, OH, which is going to mess up my oxygens to be 2. And it's going to double my hydrogens here. So 2 plus 2 more hydrogens makes 4. So it did fix my potassiums, but now I've got other problems. So I need 2 more hydrogens and 1 more oxygen. So this is going to be perfect if I put a 2 in front of the H2O. Now I have 4 hydrogens and 2 oxygens, and everything is balanced. Number 6, I've got 8 sulfurs on the left, 1 on the right, 2 oxygens on the left, and 2 on the right. But my sulfurs are way out of whack. I've got to have 8 on the right. So I can put an 8 there, but that makes 16 oxygens. So what times 2 is 16? I'm going to need an 8 in front of the oxygen on the left side so that now everything is balanced. 8 and 8, 16 and 16. For my last one, I've got zinc, hydrogen, and chlorine. I've got 1 zinc on each side, 1 hydrogen on the left, and 2 on the right. 1 chlorine on the left and 2 on the right. So this is going to be an easy fix. If I put a 2 in front of my HCl, that solves everything. I like it when they get easier at the end.